Hi, everyone. My name is Ben Goldstein, and I'm a PhD candidate at UC Berkeley's Environmental Science, Policy, and Management Department. This spring, I worked with two teammates, Michele and Rafaela, on the EFI Forecasting Challenge as part of a course taught by Carl Bettiger. Today, I'll be talking briefly about how we used GitHub Actions to automate the daily execution of our forecasts. So our team worked on the Spring Phenology Challenge. The idea of this task was to predict the timing of green up at 8 NEON sites based on photos which were indexed by their greenness. Specifically, we were trying to predict daily measures of the greenness of these photos. So our group chose to take a pretty simple modeling approach and essentially calculate a weighted average of the previous years with uncertainty using generalized additive models and a cyclic spline function. So the data with our predictions look something like this. Because we had this relatively simple model, we had some time to devote to figuring out the best way to set up the automatic code execution. So the Phenology data updated daily, and we wanted to submit a forecast every day, but we didn't want to have to, open a local R session, run all the code, and manually upload our submission every single day. So Carl introduced us to the GitHub Actions feature, which allowed us to run our code automatically. GitHub Actions is a GitHub tool that basically lets you set up automatic code execution on a GitHub server, GitHub hosted environment. You can find the Actions tab in your GitHub repository, as shown here. And to create an action, we created a file in this directory. So our main directory /.github/workflows/ file name .yaml. So this is a YAML sort of markup language file that just sort of configures the automatic or the GitHub action. So here's the full text of this file. It's a little confusing to look at right now, but I'm going to walk through it and just sort of show that really there's not that much going on. This is a pretty easy feature to use. So the first thing is that we wanted to run this forecast at a specific time every day. So we used this on schedule cron syntax. I picked an arbitrary time. This is like 9 a.m. Pacific. And so the GitHub action executes every day at 9 a.m. You can see another option for automatic running on push is commented out. If we commented out the cron and commented it on push, it would run the action every time the repository is updated, every time there's a push made to the repository, which is nice if you're doing something like package development and you want to set up test code to run automatically. The next chunk of code is some boilerplate setup stuff. We took this straight out of a template, and I'll talk more about the templates later. The next chunk of code manages the R packages that we need using the renv, maybe renv tool, which basically, I don't know a lot about this, but you provide this renv lock file that describes all the R packages that you need or automatically generate it using the renv R package. And then the GitHub environment caches the packages that you need so they don't have to be reinstalled every single time an action is run. And then finally, all the actual challenge stuff is just in these 3 lines of code. We use this R script function and then point to the automated _par.r file. So we had to write this automated par file, and it has all the code to update the downloaded data and then run the models and then put our predictions up on the NEON server. So all the good stuff is done in that file. So if you want to learn more about GitHub Actions, you can go to this URL, github.com/rlib/actions, tree master examples. They have this great selection of template YAML files that are really nice for getting a sense of the spread of applications and implementations for GitHub Actions. We used the render markdown.yaml file and then just sort of swapped out the call to render the markdown with the call to R script. And finally, all of our code for our project is at this URL, github.com/sbom-288/Phenology team. And if you have any further questions, you can reach out to me by email, ben.goldstein@berkeley.edu. Thank you for listening, and I hope that this was useful.